All right, moving on with section 1.2. Like I said, the problem that we just completed was a problem in context. There was a story behind it. But the next problem is a problem without context. There is no story behind it. It is just the graph of a random function that we're going to name f of x. So my first question, that's a review from last time, is f of x one-to-one? And remember, we test its one-to-oneness with the horizontal line test. So as I draw even just one horizontal line, bam, look at how many times that horizontal line goes through my function f of x, which means that it is definitely not one-to-one. Give the domain and range of f of x. So I remember that domain is talking about all of the possible x values. Range is talking about all of the possible y values. So I first start with domain, and whenever I look at domain with my x's, I need to train my eyes to look from left to right. So if I start on the very left side of this graph, the very first x value that I see that I'm going to make a little bit nicer is -3. So I'm just going to write -3 there. Then, if I look to the very right, so my eyes are going right, the very last thing to the right is an arrow, which means that even though it looks like the graph stops here, it actually keeps going forever and forever to the right. And forever and ever in math, we're going to call infinity. Since we can never actually touch the number infinity, we put what's called a soft bracket or parentheses there. On the other side, though, this point -3, that x value really does exist on the graph, and you can touch the x value -3. So we put a hard bracket with the -3. Now I'm going to retrain my eyes because I'm looking at my range with my y values, and I know the y values go up and down. So my eyes are going to start at the bottom of the graph, and they're going to look up. So if I look at the very bottom of this graph, the lowest point I see is right here. And the y value that goes with that lowest point is -4. And again, you can actually put your pencil on that -4, so we're going to put a hard bracket. As we continue to look up, the last thing I see again is this arrow. And even though the arrow goes forever to the right, for our domain, it also goes forever up for the range, which means that our range also goes to positive infinity with a soft bracket. Okay. Now I'm going to look for intervals of x where f is increasing. Whenever we talk about intervals, unless we're talking about this range, we always use our x values. And when I say increasing, I mean reading your graph from left to right, when is the function going up? So I'm going to trace this with my eyes. I might use a highlighter to show you. First, my eyes go down, 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 down. Then up, 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 down, 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 up, up, up. I'm only concerned with keeping the up parts of this graph. So I'm only concerned with these two sections where the graph is going up from left to right. This first section starts at +6 and ends here at +9. So when I write that interval, I just write parentheses 6, 9. My second interval of increase starts right here when x is 13 and ends with this arrow, again, meaning it goes on forever. So it goes from 13 to infinity. Since there are two sections of this graph that's increasing, we put this union symbol in between. Part D asks on what intervals is f positive. So if we think back to our previous example when we were talking about temperature being positive and negative, we were thinking about temperature being greater than 0 or less than 0. Same thing down here. When I think about when this function is positive, I'm asking when is y greater than 0. So I'm going to erase my highlighting from the first part, and I'm looking above this x-axis to determine when the function is positive. So I've got one chunk here, I've got another little chunk here, and I've got a last chunk over here. So if I look at those as intervals, this first section starts with the x value of -3 and ends with the x value of 2. So sorry, things are popping up here. So I'm going to go from -3 to +2. Since there's another section where my function is positive, I put my little union symbol. That section goes from when x is 8 to when x is 11. And I still have one more section, so I put my union symbol again. That section starts when x is 14, but it ends with this arrow, which, you guessed it, means infinity. Part E, for what values of x does f of x equal 2? So what this is really asking is, what's the x value when y equals 2, just like in our previous example. So if I look at my graph, I go up to the 2 on the y-axis, and I'm going to look all the way across to see any time my function hits that y equals 2 line. So that happens once here, and once here, meaning I have 3 x values for which y equals 2. The first x value is 0, the second x value is 9, and the third x value is 15. So I list all of those. X equals 0, x equals 9, and x equals 15. Part F, evaluate f of 11. Again, remember how our whole function is called f of x, so this 11 must be an x value. So if I look at when x equals 11, I'm right here on my graph, which means that y equals 0. Part G, what are the relative minimum values of f and where do they occur? When I'm looking for minimum or maximum values, I'm actually looking at the y values, and the where do they occur is the x values. So relative minimum means the lowest point on this graph, which happens here at -4. And when does it occur? That -4y value happens when x equals 6. Lastly, just to refresh, we're talking about average rate of change again, which just remember the formula for now. That's your change in y over change in x. So y2 minus y1 over x2 minus x1. Like I said in the previous example, I will always give you your x values. So go ahead and put those 2 x values on the bottom. And we just need to find the corresponding y values. So when x equals 6, if I look at my graph, y equals -4. And when x equals 11, y equals 0. If I finish out this calculation, -4 minus 0 is still -4. And 6 minus 11 is -5. Since they're both negative, it reduces to +4/5. And since this problem is not in context, we do not have to explain that. Your average rate of change is just 4/5.